So basically now our main agenda is to make a stock price prediction. Okay. And to make a stock price predictor, let me remove a lot of things from here. Let's remove this part from here. So these are traditional steps, if you look closely, of these are traditional steps, the one at the top, are of any machine learning algorithm. If you want to make any algorithm of your choice, or basically train a machine learning or a deep learning model on any data set, it usually starts with an agenda. What do you want to make? It starts with an agenda, right? For example, you want to make a cat versus dog classifier. This is your main agenda. Then you will see, okay, from where exactly I can get the data, from where I can exactly explore the data. Do I need to do some data cleaning, data pre-processing or not? Do I really need feature engineering? Okay, these are some of the steps that we usually need in machine learning algorithm, but they are the same in deep learning as well. So then we'll define the model. It can be a machine learning model. It can be a deep learning model. Then we will train the model. Then we will evaluate how well the model is working. And then we can eventually deploy the model or run the inference, or basically getting the predictions from the model. This is a traditional approach. This is the approach that we usually use for any machine learning or deep learning project. Okay, if it is computer vision, there are some extra step that has to be added. Some steps can be replaced, but this is a traditional approach. Okay, and you might have made some of the projects with Harshvardhan sir regarding the same as well. Yes, did this. That's great. Okay, now the thing is, if my agenda, because this is the agenda that I want to replicate. If my agenda is to make a stock price predictor, my agenda is to make a stock price predictor. How should you go ahead? From where exactly you will get the data? Because the agenda is clear. I want to make a stock price predictor. What should be the next step? What do you think should be the next step? Do let me know in the chats. Data collection. Get data from NSC website. Okay. Anything else? Kaggle, Yahoo Finance data collection. Okay, I think my speaker is connected. Better. Okay. So it's time series data. Okay, that does make sense. But everyone is talking about will get the data from Kaggle, from different sources, but no one talked about which kind of stocks. Can I have a model that will work for all the cases? We need to basically, first of all, define, right? Which kind of data I want to make an algorithm on. Do I want to work on NSC, like Nifty 50? Do you want to work on Sensex? Do you want to go for Nifty 100? You want to go for Nifty Bank? Or do you want to go for any specific stock of your choice? On which specific data you want to make a stock price predictor? That is the question that has to be answered first. Right? Once we have got the point, like now my task is like Nifty 50 is the one. Okay. Once we have that thing in mind, I don't want to make a stock price predictor in general. I want to make a Nifty 50 stock price prediction algorithm. Okay, now my agenda is clear. Now I'll get the data of Nifty 50 stocks. Shouldn't it work for all of them? In a broader term, if the market changes, obviously a lot of things also changes, but specifically it's not mandatory. Okay, so it would be better if you can have just specific to one stocks, train the data, and then get the prediction from that model. That's the best thing we can do. Now the thing is, our main task is to go for, let's suppose, Nifty 50 stock price prediction. From where exactly do we get the data? From where exactly we can get the data of Nifty 50 stocks? Yes, we can get it from NSE website, we can get it from Yahoo Finance, and you can get the same thing from Kaggle as well. Okay, so there are a lot of sources available. Now, for how many years of data do we need? How much years of data we need to have? 10 years? Last 10 years? 5 years? Lifetime? As much as possible. That's correct. The more, the better. That is the main agenda. Okay. The more data we have, the better my algorithm can train. Okay. So I can get as much data as possible. Clear? So first thing is I need to go for Nifty 50. Second thing is I need to get the data of last 25 years, let's suppose. Okay. Then once I have the data, then what I will do, here you can see, first of all, I'll go for Nifty 50 stock prediction. This is my agenda. Then I'll search for data set. And if I get the data, then we'll see, okay, if I talk about data set for Nifty 50 as well, it's whenever you are searching for the data set, it's not like you will get one price. Okay. Inside a data set, we have opening price. For every day, we have open price, like which is opening price. What else do we have? We have closing price. We have uh, uh, maximum. We have minimum. We have volume. These are the things, high or low. Yes, this is high. This is low. Okay, these are the main 4 to 5 things that you usually have in a data set. Okay, now tell me, when you want to train an algorithm, should we take opening price based algorithm? Like we need to train the algorithm on opening price or closing price or high or volume or what? Because for every day for every day we have an opening price, closing price, high, low, volume. So all of them are prices, but here comes the volume is a different quantity altogether. So which one we should take? Daily average or closing price or multiple features as per interest, or we need to see which one is working. Can I say I don't know right now? I'll see which one is working best. We need to try all of them and see which one is working. Okay. So we'll basically have the data. Right now I have these 4 things. So these 5 things. So I'll search for the data, then I'll see what exactly I need to do. And for that purpose, if I go to Kaggle and if I go to my profile and if I go to data sets, if I scroll here, I'll share the link in a minute as well. If you click on this one, this is the Nifty 50 2000 to 2025, last 25 years data. Okay. And inside it, if you scroll it, this is what we have. This is the exact date. This is the opening price. This is the high. This is low. And this is closing. We don't have volume right now, but this is the data that we have. If you don't want to take this data, you can take any other data of your choice as well. That's totally up to you. Eventually, we want this data. Okay. This is a publicly available repo. Once I have this data, what should be the next step? Now I have the data. What should be the next step? Perform EDA? Data exploration? Yes. These are the things that you have discussed in previous classes as well. Okay. Will it include real-time data? Okay. So I've like collected this data from the internet, like from the official website from 2001 month till I think June. The last date was June or July 2025. If you want to add that data, the recent update data, you can go to the website, download last couple of years of data, couple of months of data, combine that as well. Okay, it's still May. Okay, yes, makes sense. How do you collect the data through web scraping? No, You can go to their official website, stock exchange website. From that, you can directly download the data. It will let you download the data for 1 year at max. So you need to combine the data, download the data for 25 different CSV file and eventually combine it. Okay, so I made the things easier for you, showing you the whole data. Now, I'll do the data exploration, I'll do the data cleaning, I'll do the feature engineering, I'll do the data normalization. These are the things that you already know. Then we'll define a model. Okay, now let's suppose I have a model. I've defined a model. Okay, this is the dataset link I'm also attaching here. So you can take a reference from this anytime. And eventually I'll share this notebook as with you as well, this Calidra notebook. Now the thing is, okay, let's suppose this is the data that we have. This data I need to pass to a model, right? How exactly should I pass this data to a model? Or to be more specific, okay, let me do one thing. Let me create a new code file here, create a new notebook, so that I can also write the code with you, along with you, side by side. Okay, so here let's move this one. It is connecting the resources. This one is not having any accelerator. So I can go inside this folder. This is the data.csv. So eventually what I can do, I can import numpys as np. I can import pandas as pd, and I will load this file as well. This is your main data file. So your df is equal to pd.read_csv. So df.head, this is the exact data that we have. Okay, I'm executing it right now, so it will take a couple of seconds to run. So, but once it is done, it will show you the whole data. Now, my question is pretty simple. Okay, let me load the data first so that you can see how the data exactly looks. Then I'll train a lot of algorithms on top of it. So session just started. This is the data that we have. These are the top 5 rows. And eventually I can also go for tail, which will return you bottom 5 rows. So this has the data till May 26th. So we have, if you look closely, how many days of data do we have officially? How many trading days data do we have officially? 6314. From 0 to 6314. So total is 6315. So I have total 6315 days of data. But if I make a calculation, 365 days in a year, and in 24 years, I need to have more than, so it should be around 9000 days of data. Why I just have 6300 days of data? We got only weekdays. Okay, market is open only on weekdays, so we don't have those days. And here you can see as well, after 3 4 5 6 7, so if I'm going for 10, so you can see after 3 4 5 6 7, on 8th and 9th there is no trading day. Then we have 10 11 12 13 14, and after that there will be 2 days of off as well. Okay, so this is the data that I have. Date, open, high, low, close. Okay, it started from 1400 and now the price is at 25,000. Okay, it's just like around 20 times, like 15 to 20 times. Now the thing is, okay, I have the data. Now eventually when we do the data exploration part, you usually check, do we have any null value or not? And here you don't have any null value. So you can also go for like, do we have any duplicate data inside it or not? So inside that you can also go for df of date dot is dot n unique. This will give you how many unique days of data do we have? 6315, and total number of rows are length of data frame. So the answer is 0. That means we don't have any duplicate days. Okay, this is a very basic technique I'm applying just to cross verify everything. Now my question is, whenever you plan to make an to take a machine learning algorithm and train it on my data, I cannot directly pass it on my data, right? I cannot, okay, this is a classification based problem or regression based? This is a regression based algorithm. Good. So my funda is, I have the data. I have opening price, closing price, high, low, no volume. How should I pass this data to my model? How exactly should I pass this whole data to my model? Can I pass this whole column, open column to my model, or high column to my model, or low column to my model? How exactly I'll train it? This is aggression based algorithm, and it is eventually in like I need to convert it into features and labels, because on machine learning model training, I need to give input as well as output. So how I will create those input outputs? That is my question. Split it, feature engineering, how exactly? How exactly I'll perform feature engineering in such a way that this data will be converted into inputs and outputs, features and labels. Data month, like new features are formed, range. I don't know what you want. Like, could you please clarify? But that would be, then that would be great, range. Kushag, close as predictor variable. Okay, so do you want to predict a closing variable? That's something we can think of. Recent ones, inputs, lag. No. So now we need to think about it. Okay, just see what exactly do we want to do. How many days of data do we have? 3,615 days of data. Now, what I need to do, I cannot directly pass the whole open column to my model. In that particular case, the model will have 36315 rows as an input, and the output should be stock price of tomorrow. But the model don't know the stock price of tomorrow, right? So how exactly we should make this data set in input output pairs? That is the main problem. So for that purpose, what I'm going to do, just look closely. I'm taking this blocks of data. Yes, we need to convert it in blocks of data. I'm taking opening price. This is the whole data, right? So what I'll do, I'll take, okay, let's take first 10 rows. So this is what I have. This is the data of first 10 trading days. So what I'll do, I'll take first 5 rows. First day, second day, third day, fourth day, fifth day. I'm taking first 5 days of data as an input. Okay, so if this 5 days of data is the input, what should be the output of the model? If 1, 2, 3, 4, 5. I'm taking first 5 days of data as an input. So output should be this one, right? So this is the first combination that I have made. Sixth day is the price. Then what I'll do, I'll take next 5 days of data. Okay, and rather than taking next 5 of data in this particular way, I can directly go for, can anyone tell me what this is called? Whatever I'm doing. Anyone want to make it a guess? This called a sliding window operation. I'm taking first of all the first 5 rows. Sixth is the output. Then I'm taking next 5. Next one is the output. Then I'm taking next 5. Next one is the output. Next 5. Next one is the output. Okay. So this is how I'll make input output pairs. Okay. How is it happening? Basically, I'm taking t minus 5 days as an input and 6 days as an output. Okay, so I'm taking first 5 days as an input. The 6th day is the output. Okay, then I'm taking next 5 days as an input and the day next to that as an output. So basically, okay, why I'm doing it? So that I can have input output pairs. Because eventually what I am going to do, I cannot pass directly the whole data to the model. I need to give the model something like this. Just give me a second. So for the model, I need to give the input something like this. So this is going to be the input and this is going to be the output. So this is one pair that I have defined. In the exact same way, I need to generate as many pairs as I can. This is something that has to be given to the model for training. This is one pair I have made that will take first 5 days data as an input, next day data as an output. And we need to do it for all the pairs. We need to keep on sliding the things so that I'll have a lot of pairs as input output. Then only the model will take then only the model will learn how to predict. Now, Ajay said, why 5 days of data in specific? Why 5 days? Can I take 10 days as well? Yes, I can. Can I take 20 days? Yes, I can. Can I take 60 days? 100 days? Yes, I can. 5 days is easy for me to show you. That's why I have taken 5 days. That's the main part. It's not mandatory. And usually the more days you will take, the better the model will become. Okay, so this is a sliding window operation we are doing. Okay, and now there's someone who said about DSA. So now let me tell you what DSA is. Now, whatever we have just seen, instead of this, please this. Okay, this would be better. Okay, good. So this is the first pair that we have made. Okay, and now we need to make all the possible pairs that are there. So we are making batches exactly. Okay, now the thing is, now I'm going to write a for loop that will make all the batches for you. Okay, and it will go, first of all, let me run it for this one, then I'll do it for rest of them. So I want to basically go for a for loop that will start. So for I in range, the loop will start from 1 and go up to, for example, 5. Okay, let's go till 5. So eventually what I'm going to print, I'm going to print this. I'll start from I and I'll go for I plus 5. Can anyone tell me what will happen? So basically, okay, this is printing it as a series. Can I convert it into a list? So basically, I'm taking the same kind of a bunch. These 5, these 5, next 5, these 5. This is going to be the input of the model. And the output would be data of open of ith or I plus 1. Okay, data of I plus 5 plus 1. Okay, it should be I plus 5, sorry, not plus 1. So we have made the same pair. This is the input, this is the output, and in between I can make this. So through a for loop, I am printing first 5 days as an input, next day as an output. Does this make sense what we are doing? This is just a for loop, which will convert input and output pairs. Now, what is this 5? If rather than writing here 5, what if I'm writing here 10 and here I'm writing 10 and here I'm writing 10? What will happen? what will happen? It will take 10 days data as an input, 11th day as an output. Next 10 days, 11th day. Okay, so can I do one thing? Let's define it as a batch. So I'm defining days is equals to 10, and here with respect to days, it will do rest of the things. Days, these many days, these many days. So just change the number of days and it will do the things for you. It will make the batches as it is. Does this make sense? And now if I want to go for take 3 days as an input, 4 days as an output, it will go ahead in that way. Okay. And now if my task is to go for all the possible pairs that are there in the whole list, then if I want to go for all of them, so in that particular case, I need to go for the whole data set. I need to go for the whole data frame. This length of data frame minus something. Okay, so now I'm going to write that program. Okay, so basically in that particular case, I'll take the, okay, I'm modifying the things a little bit. There are chances that I'll not get it in the first go, but I'll get it for sure. So this is something that I have, and there will be easier way of writing the same thing as well. So this one, I plus I of 10 days I want to go ahead with, but the same operation I want to run it throughout the data set. So rather than printing here, passing here days, I should have passed here from 0 till I got confused a little bit. So this is the window that we are taking from this one to 10. So let's go for a for loop. This one is of days. So for I in range to the length of the data frame. Okay, but not length of the data frame minus days as well, because I'm also going for a couple of days is equals to probably 5. Length of the data frame minus days, and eventually I'll print I of this. Yes, the rest of the thing would be same then. Hopefully the code is correct, but let's give it a try. For I in range of length of data frame, why is it trying to give me an error? Okay, so this will make a lot of pairs, hopefully, if it is running. So here you can see these are the pairs that it has made. It has made like more than 6,000 pairs. Okay, and they are input outputs. Does this make sense? So this loop is making all the possible pairs. So they are your inputs and they are the outputs. So I can also take, what are the inputs? X. What are the outputs? Y. So this thing would be x dot append. I'm going to appending all the inputs here. And here this is going to be y dot append. This is going to be all the outputs. And now I don't want print statement. It's just taking a lot of space. And here I can pass tqdm because I want to check how much time it's gonna take. So from tqdm dot auto import tqdm. This will also tell you how many time this loop is running. So this loop has made 6310 chunks. 6310 input output pairs. Does this make sense? Does this make sense to you? What is TQDM? TQDM is a library that will show you the progress bar. That is it. Okay. If the data is not equal batches, take last batch only has 3 data remained. Okay. So the point is correct. Last batch should have 3 data points correct. But if I show you, like what do we have in the last X of the last? So X of last also have 5 pairs. Okay. So because that's why I have reduced minus days. So this is what DA says. Okay, if you don't have any algorithm, don't have inbuilt function, how will you write the codes by yourself? How will you make the pairs by yourself? That's the main thing. Okay, where did you introduce the regression model in the code? We have not introduced model yet. We are just preparing the data so that we can pass it to any model of your choice. We are going to give it to regression model. We are means machine learning model. We are going to give it to deep learning model as well. Okay. So right now we have make pairs for 5 days. Okay. So this is X underscore 5 days pairs and Y underscore 5 underscore days pairs. Okay. So this is one data that we have got. And this is the whole data that we have so far. Okay. Now, rather than having 5 days of pair, like we can have 10 days as well. Does this make sense? Rather than just having 5 days, I can also have 10 days. And to just make it in form of a modularity, I can also return it. Like I can return, like just see closely what I'm going to do. I am returning this X and Y, and I'm passing everything inside a function. So define make batches, and which will just take days as an input, days as an input, yes, and it will return you X and Y as an output. So you can now call this function anytime. Expected or colon, obviously it should be there. So I can write X comma Y is equals to make batches, and inside make batches I'll just pass 10. So it will make all the batches of 10 days. If I want to make the batches of 20 days, so it will make couple of less batches, and this time I'll take 20 days of data as an input and next data as an output. Does this make sense? So now this is a function that I can call for different batches. I'll make a batch for X underscore 20 days, Y underscore 20 underscore days. I can also make another batch for 30 days. I'll also make another batch for 60 days. I'll make another batch for 120 days. You might be thinking why I'm making so many batches. Because if you look closely, I don't know which batch will work best. Which batch can give you the best accuracy, I don't know. Right? So I need to try out different batches and see which batch can give you best accuracy. Does this make sense? Because right now I don't know which batch will work. So I'll try it all of them. If you want to go for even smaller batches, good luck for you. Just go for 15 days batches. That will also work. So this time it will have 15. And can I go for more than 120? Can I go for 150? I can go for that as well. Because right now I don't know which one will give you the best accuracy. So I'll take the models, train it on, okay, I'll take different models, train it on all the batches and see on which batch we are getting the best accuracy. Okay. Now the thing is, so far it is going good. Okay. These are the batches that we have made. So eventually what I can do, I can take any machine learning model and train it on it. Okay, so I'll take the inputs, I'll pass it as an output. Obviously, I need to normalize the data as well. So the data would be in a specific range. But even if I don't normalize it, it's not like the model will not work. The models will still work. Okay, so what I'm doing just to make the things a bit easier, because machine learning is something you already know. So I'm using use linear regression minimalistic code to train on this data. Okay, and right now I'm just giving you this sample data. So it will import linear regression. It will define make batches, and it is converting into NumPy array, defining linear regression and loading it. So I'm just copying and pasting the code right now, just copying and pasting the code. It will make all the different batches. And because the batch is already made, so I don't need to make a batch right now. I'm converting into NumPy array. This is already imported. And then I'm defining linear regression. Then I'm fitting the data. Then I'm predicting the data. Now tell me, and here I'm defining a couple of models, a couple of accuracy metrics to see how well the model is performing on unseen data. And you can see we have mean squared error of 10,000 and we have R2 of this one. So the model is trained. Okay, now eventually what I need to do, I need to see how well the model is performing. Okay, mean absolute error is MAE. Okay, then we have RMSE as well. So they are basically different ways through which we will check the accuracy of the model. Okay, because they are regression based algorithm. In regression based algorithm, we don't have accuracy. Okay, root mean squared error, yes, that is RMSE. We can also go for that. So right now here you can see we have got that the model has, this particular model has mean squared error of this much. Okay, so basically this model is working. All I can do is try the second model with x underscore 20, y underscore 20, 20 here as well. And let's pass 20 here, eventually here, and here. And now the data is trained on the batch of 20. Okay. So basically, I can take each and every batch, train it on this algorithm and see how well the model is performing. This is one thing. Now, eventually what I'm doing, I'm using the same model for same data for training. And on the exact same data, I'm also testing my model. This is not good, right? I need to split the data into train test as well. I need to split the data into train test. And not only train test, but train test validation as well. But that's for neural network. Right now, I'm just performing machine learning algorithms. Okay, so can you do one thing? Inside this batch only, once we have it, okay, I want to modify this batch a little bit. Okay, so I'm giving this code back to ChatGPT so that let it do the work for you. Okay, modify this make batch function such that it will return x underscore train, y underscore train, and x underscore test and y underscore test. It will also have an additional parameter which is split. Based on that, the split is made. Make sure to shuffle the data. Finalize the function. Okay, so this time we are trying to modify this function so that it will not only take the xy, it will not return you xy, it will also return you x train, y train, x test, y test, and this is the code. So this one will take x train, y train, x test, y test. This one will make the whole data set. I'm converting into an array. From this, I'm shuffling the data. And after shuffling the data, I'm getting a random first couple of years. So for example, 0.8. So this one will split the data into train and test. Okay, so this one will return you train and test, validation, and so on. So what I can do, here you can see it has also mentioned this time, these batches will not work. Which batch will work? This batch will work. So this one will return you 15 batches, 80% for training and 20% for testing. And this is what we have. And once we have it, now I need to pass here, like modify this one as well. So it will basically take x train, y train, x test, y test. And now I'm checking the model accuracy or how well the model is performing as per the unseen data. And Here you can see I'm importing them. This part is not needed because I've already made it. Okay, sorry. This part will be needed because this one has made this batch. Let's define the function here. Let it make the batch here. So X train, Y train, and now on unseen data, I'm predicting how well my model is performed. So this is a better thing. Okay. Anyone facing any difficulty so far? What we are doing? Now we'll add some more complexity into it. This is just to show you that what we are doing. This is just about preparing the data. Okay. Now I'm going to make the things a bit complex. Now tell me, please summarize. Okay, let me summarize it. That is important. So I have loaded the data set, but the main issue is I have the data of last 25 years. How should I give this data to a model? Because this is a supervised learning problem, a regression based problem. So in supervised learning, I need to give input output pairs, right? So I need to define how many inputs, how many outputs. Output should be one value. How many inputs? How I will convert this data into input output pairs. And for that purpose, I have written down this function. This will, based on my cases, based on whatever number of days I want, it will make the model for these many batches and train it. Okay. And I'm also converting into train and test so that I'll also have some unseen data to check how well my model is performing. Okay. So that's basically it. Now the main thing is if I go back, right now I'm training this for 20 size batch. I can train it for 15 size batch as well. So this is the MSE that I have. Okay. If I go for 30 size batch, this is the MSE I have. MSE basically means the lesser the value, the better your model is. The lesser MSE, the better your model. If I want to go for 60, it's even lesser. If I want to go for 120, now it's high, it's going high. So I think 90. Okay. So, okay. Now in the exact same way, because in linear regression as well, weights are there that are randomly initialized, and after that when we train it, so that will be changed. So based on that, the MSE will also change. But here you can see 60 is a sweet spot that I've found so far. Okay, this is a very basic analogy I'm taking. I've not done it for multiple iteration. I am going to run it for multiple iteration as well. Okay, now I have a lot of independent things that I need to find. Okay, and now let's go back to see how many independent things that I have that I need to find. Now, right now, I don't know how many days I need to go ahead with, right? I don't know if I should take 30 days or 40 days or 50 days or 60 days. 60 are the days, 60 days as an input, 61st days as an output. And then next 60 days, 61st. Next 60 days, 61st. So this is input output pair. This is input output pair. And if I go back and show you these input output pairs, so X train, because this is a numpy array, so dot shape of it will return you. So this has made 5004 samples of 60 inputs, and Y underscore train will have the same samples, but one value as an output. In the exact same way, I can go for X underscore test dot shape. It will be around 20% of it, and 20% of it would be the output as well. Okay. Now the funda is there are a lot of independent variables. First thing is I don't know how many days I need to go ahead with. So I need to find 30 days or 40 days or 15 days or 100 days or 200 days or how many days. This is first independent variable that I need to find. Second parameter is right now we are doing it on which column? On open column. But it's not mandatory that open column is the one which can give you best model. You might get it for closing price as well. You can get it for maximum. You can get it for minimum. Does this make sense? Right now we are making batches on open, but it's not mandatory that open is the one that can give you better, that can give you the best model. So now I have two problems. Which column I need to choose? I don't know. How many days I need to choose? I don't know. One more thing. Which model will work? In a regression kind of a thing, in machine learning specifically, we don't have one model. We have 4 to 5 models, even more than that. So which model we should take? I still don't know. And right now I'm just at machine learning. If I want to go for deep learning, in deep learning, I still don't know how many models I should take. So here I have a lot of computations that has to be done. So if you go here, so this is the problem. I don't know which column and I need to take. I don't know how many days I need to take. I don't know which model I need to take. It's random forest. Okay. So what should I do? Should I go for all the possible combination and check which one is working the best? Yes. Yes. I need to go for all of them. So can you make it a random guess how many models I'm going to train this time? Isn't it time consuming? Yes, it is. But is it going to give you the best model? Yes, it is. So
Yes. Yes.
coming back to the same point, it's not about finding just one model that will do all the things for you. It is about finding the best model that will work for you. We are going to train a lot of models, but at the end of the day, it will be worth it. Okay, so if I just want to give it the clarity, how many models I'm planning to train. So I have 4 columns. Based on that, I can make the models. Okay, no 32 or 32 is not the answer. I have 4 columns. So based on open columns, I can make 50 size chunk, open column 15 size, open column 32 size, open column 45 size. In the exact same way, close 5, close 15, close 30, close 45, close 60, and so on. So I have 1, 2, 3, 4, 5, 6, 7, 8. 8 fours are 32 models, but not that. I also have 1, 2, 3, 4, 5, 6, 7, 8. 8 different model for every case. So eventually I'm planning to make 256 models. What about which hybrid model you are taking? You are talking about bagging and boosting? Because we have those models here as well. Okay, so we have XGBoost, we have bagging boosting models as well, like random forest decision tree. Okay, so the thing is, LSTM-RNN, yes, that is the point. And they are just machine learning models. Apart from that, there are some deep learning model as well. Also, I need to try. For example, 8 are machine learning models. I also have 5 different deep learning models. So total, I have 13 of them. So eventually, I need to make 400, more than 400 models. I'm planning to make more than 400 models and see which one is working the best. And see, whenever you will do this thing, this is the best thing you can do for this. Because eventually you don't know anything, which one will work. It will take a lot of time. Yes, it will take 3 to 4 hours to train. Yes, 3 to 4 hours to train all these models. I have the code ready for that. I have trained that as well. And I'll show you which model is working the best. Yes, Arima, Sarima, they are also the model that we can give it a try. Why more than 4 models? Because of the combinations. One model I'll train, okay, linear regression I'll train for open of 5. I'll train linear regression for open for 15 days, open for 30 days, open for 45 days. And that is just for linear regression. Okay, then I'll go for closing and different days for linear regression. High, different days just for linear regression. So doing all the M into N into J, multiply them, so it will give you more than 500 models. All the combination, yes, it. 4s are here, 8 are here, 8 are here. And not 8 here. I have not added those models, deep learning model. What is bagging and boosting? Bagging and boosting are the techniques which will help you uh, basically find the weaknesses from one model that the model has not predicted correctly and using another model for that. Okay, like ये मुझे लास्ट में एक बार याद करा देना, लास्ट में डिस्कस कर लेंगे इस पे, ये मशीन लर्निंग का पार्ट है। ओके, 13 into 4 into 8, यस। सो दिस इज वन थिंग। और इसमें एक और दिक्कत भी है, नॉट ओनली दैट, पर ठीक है वो लास्ट में डिस्कस करेंगे। सो दीज आर द थिंग दैट आई हैव। सो इवेंचुअली व्हाट आई नीड टू डू right now, let's go for this one. I'll train all the model and see which one is giving you the best accuracy, and based on that I'll decide. Okay, ठीक है। लीनियर रिग्रेशन के काफी सारे मॉडल्स हैं, मशीन लर्निंग के मॉडल्स पे मैं अभी नहीं जा रहा हूं। नाउ आई विल जंप ऑन द मेन मॉडल फॉर टुडे, दैट इज, और ये हमने लास्ट टाइम डिस्कस भी किया था, and that is, let's wait for it to load. Where is it gone? Okay, here it is. So if you look closely, there are machine learning techniques that will use for computer vision, and inside it we also have models that will basically go for, that will do the time series analysis for you. Now what is time series analysis data or sequential data? Sequential data is the data where sequence matters. For example, if I'm opening any x train for x train of 0, this is the batch of 30, okay, and this is 0. Now this is the data in a sequence, and this is the output, right? If I change the sequence of it, do you think the output should be this one? From changing the sequence, I mean to say changing the columns. Think of it as a data frame. Okay, right now, for example, if I'm taking this data as an input, okay, and the output is the next day's data. For example, if this is what we have right now, it makes sense. But the thing is, even if I'm changing these, think of this as first column, this is second column, this is third column, this is fourth column. Or let's do one thing. Let's load them as that as, okay, we can load them as data frame as well. But think of it in this manner. So if I'm changing these sequences, what do you think? It's important or it doesn't matter?
It's important.
It's important. The sequence matters here. Okay. In the exact same way, in text as well, sequence matter. For example, this I'm writing, this is good, not bad at all. And this is bad, not good at all. Both of them, it's just the change of sequence. It will change the whole thing. So wherever the sequence matters, it's called as sequential data. Time series data is also sequential. Text is also sequential. So same model I can run on sequential data as well as time series data. Mostly we can run it in this way. Okay. Will the result change if the sequence changes? Yes, it will. Okay. Now there are some special models that will work great on sequential data. And in neural networks, those models are called as RNNs. So we have ANNs, which is artificial neural network. We have RNNs, which is called as, anyone know the full form of it? Recurrent neural network. We call it recurrent neural network, right? Okay. And in recurrent neural network, we have different types of it. We have simple RNN, we have RLSTM, we have GRUs, we have bidirectional. They are just different variations of RNNs, or some better and better variations of it. Okay. And then comes a totally new architecture, transformers, that we are not going to discuss today. Okay. So they are different techniques or different layers, to be more specific. Okay. For example, in neural network, we have dense layers. In convolutional neural network, we have convolutional max pooling layer or average pooling layer. Here I have LSTM layer, GRU layer, bidirectional layer. There are different kind of layers do we have here as well. Okay. So eventually what I'm going to do, I'm going to use this kind of a network. Okay, this, okay, are you guys clear about what is sequential data? Sequential data is where the sequence matters. Okay, now let me do one thing. Let me make your life a bit more miserable. Okay, x train and y. Okay, x train, because I want to basically make x and y underscore train make a data frame. So it will write the pandas code to show it as a data frame. This is just to show you like what's happening. So this is the data frame. This is the chunk that I have, like from 0 to 59. From 0 to 59, I have 60 days of data as an input, and the output is this day. Okay, in the exact same way, just to make the things a bit easier, let's go for a batch size of 10. So now I have 10 days data as an input, 11th day data as an output. Any issue in this? This is exactly what's happening, right? And whenever I'm training a neural network, what is happening? If you look closely, if I'm going back to, because this is a problem that a lot of students face, they will not exactly understand what is the need of sequential uh, data to have a different mode of training the model. Why don't uh, the normal model work? So if you look here, I want 10 days of data as an input, right? So can I have 10 neurons here? It will work. And eventually I need to remove a layer. Let's remove another layer. And let's, okay, this is fine. Okay. In the output layer, how many neurons I need to have? 1. That's correct. So this is how the neural network looks, right? Eventually in between, if you want to edit the number of, if not layers, edit the number of neurons, you can do that as well. This is how the neural network looks. So in the first neuron, which value will go? This value will go. In the second neuron, this value will go. In the third neuron, this value will go. In this neuron, this value will go exactly at the last neuron. The values are passed. Here we have random weights. Then we have activation function that will basically decide neuron will fire or not. And eventually this one has a value, this. So this input has to be mapped with this. If it is not mapping, all these weights and bias has to be tuned. These are the parameters that will be tuned. Okay. Now the thing is, this value is going in this particular neuron. This value is going in this particular neuron. And so on, right? These 10 values are going in these 10 neurons in exact same sequence. Anyone has any doubt in this? No, right?
Go ahead, yeah.
Once the back propagation is done, the weights are updated, then I'll take next layer, next 10 values, it will go here. Output, this one, then it will back propagate as well. Now, the thing is, imagine if I'm doing something like this. What have I just done? Can you tell me what have I just done? The data is changed? Yes. Now what have I done? I have changed the order of it. Okay. So for example, first two columns are correct. Third column is now change its position with this one. So if I'm changing their positions, their orders, what will happen? If I'm changing the order in which the data is going to the model, what will happen? The output
Data will
differs.
change.
Okay, I'm just changing the inputs. The output is still the same. Output column is still the same. I'm just changing the sequence of inputs. For the whole data, I'm just changing the sequence of it. Eventually, earlier, I'm taking first 10 values given to the model. Now as well, I'm giving 10 values to the model. Because it is a neural network, all these 10 values are going side by side to the next layers. If this input does not depend upon this input does not depend upon this input does not depend upon these inputs. All these values are going in parallel, right? That is the biggest issue. So even if I'm changing the sequence of it, the model will still learn. ANN model will still learn, but that will not give you good accuracy because all the values are going side by side. But eventually, what do I want? I want my model to not take these 10 inputs and give you this output. I want my model to also learn this value that we have depends upon this value. This value also depends upon these two values. This value depends upon these four values. This value depends upon all the previous values. And this value don't only depend upon these 2, 4, 10 values, but the order in which the values are there, that's also important. So for that purpose, we need a different kind of architecture that you can see here. So here you can see these X are the inputs. The inputs are not directly given to the next layer, but the input is also given to the layer next to that. So here, as you can see in this particular network, the data is directly given to the next layer. But imagine this input is also given to this input. So that this input is not like the output is not dependent upon this, but also this also depends upon this one. This input depends upon this one as well as this one. So this is how we are giving not only getting the output, but input of the previous thing as well. Okay. And all the 3 or 4 kind of network that we have, LSTM, GRU, all the things will take sequential data in this particular way. But ANN can take all the data parallel. The ANN will also train the model, but not in the best way. That is the main thing. Okay. It is a time series data. Next data is also dependent on the previous data. Yes. Text is also the time series kind of a thing as well. It's not called as time series, it's called as sequential data. Text data is also sequential data because there as well, sequence matters. If sequence doesn't matter, I like coffee, or like I like the movie, not bad at all. I don't like the movie, not good at all. Both of them means the same thing. Okay. I hope the funda is clear to you. Now, what I'll do, does it has memory? Yes, it has memory. Okay. How will ANN work in this particular case? Because ANN will just take the input, map it with the output. It's just like a traditional regression technique for it. You don't know like this, the sequence has to be taken care or not. It's just about it will take the input, it will spit out the output. That's it. Yes. Can we generalize that ANN would not understand the sequence? Exactly. ANN will not understand the sequence. RNNs, LSTMs, GRUs, they will understand the sequence. Okay, I'll not discuss deeper into how RNN works, LSTM works. There are a lot of lectures available on the internet and in our recorded courses as well, but in recorded courses, you don't have the access to. But yes, those models will work. And I'll not dig deeper into how those models work, but they basically are sequential models. Okay, now what I'll do, I'll go to the main code now because now I know how to make these batches of any column of your choice. And here I can modify this column as well. That rather than passing the df of open, Here I'll pass a column. Okay, and here I'll pass the column name, for example open. So it will take, this is the, okay, by default it is taking the column name. Let's pass the column here. So this time what it will do, I also have one extra column here. So if I'm executing it, hopefully, I'm not pretty sure if it should work or not, but here I can pass the column, and if the column is close, so the batch it is going to make is on close column, on closing price. In the exact same way, I can go for open, close, min, max, or low, high. Okay, so now the code is also modular. Okay, so now what I need to do, I need to go for defining all the models right now. So now, without wasting any time, let me go to a notebook, and the notebook is, where exactly is the notebook? Is this the notebook? It will not. Okay, if you open this notebook, this is how it will look. But if I click on edit, it will show you in a better manner. Okay, and in the exact same way, I think on GitHub and on a projects, this, yes, this one, stock price prediction Nifty 50, yes, this is one. So open in Colab, and this is also the file that you can see. I just want to show you what exactly is happening here. Okay, this is also not visible, totally fine. But if you see here, we have data.csv, we have models.csv. Okay, and I'll show you at the end what this model.csv is. So here, what I'm defining the problem statement that I have the data set, I have open, close, high, low values. I define it into pairs of input output from 30 days to 250 days. I'll define some basic ML algorithm, tree-based ML algorithms, other ML algorithms, and also deep learning algorithms with deep learning layers. Okay, then I'll train the model. I'll check which model is giving you the minimum mean absolute error or minimum root mean squared error. The minimum the value of these things, the better my model is. And then I'll save all the models and compare all the models. Okay, so you can run this whole notebook, but for that purpose, you need to, before running it, you need to upload the data file here. And to upload data file, what you can do means if you go to this code, you can click on open in Colab, this notebook will open. Once it is open, download this models.csv, sorry, data.csv and upload it here. So the data will be loaded. So now if you execute it, this is the data that we have. Pretty simple, right? Then I'm defining a data pre-processing function which will generate chunks for you. Chunks of open, close, high, low, all the columns, 30, 45, 60, 90, 120, 150, 200, 250, all of them. So it will generate chunks. Okay. So chunk pair has all the chunks. Now I'll define all the models. So here you can see right now I'm defining some very basic. Okay. If you want to define, so here you can see I'm defining a simple RNN layer. Simple RNN layer will look something like this. Sorry, well this, but here, rather than giving the whole data directly to the next layer, there is already a connection between these layers as well, these neurons as well. Okay, so I'm defining the simple RNN layer. The input shape can be anything. It can be 30 days as an input, 50 days, 100 days, 120 days, but I'm defining simple RNN as 50 and the output is one neuron. Simple, build a simple RNN. Here I'm building a simple LSTM with LSTM layer, simple GRU with GRU layer with the same neuron and single a bidirectional layer as well. Okay, so I've defined all the basic deep learning models. Okay, in functional parameters, in functional thing. Now, can you tell me what's happening here? What is happening in this code? You can say it's a pipeline. Okay, or basically I've defined a ML models list. Inside that I have defined all the machine learning models. And in DL models, I have defined all the deep learning models that I'm calling from these functions. So basically, I've defined all the machine learning models and deep learning models here. On top, I've already made a list which has all the chunks. So now, shall I train the models? It's time to train the models, right? So if I go here, this is the code which will take each and every model and train it. It will take machine learning models separately, deep learning models separately, and it will train all the models. And if you look closely, I have added TPU here, GPU here as well. T4 GPU is working. And even after using T4 GPU, it has trained, it's being trained for 1 hour 43 minutes. This is the total time all these model had took to train. 1 hour 43 minutes. And if you are not using uh, uh, what I would say GPU, then it will take like at least 10 times, like around 20 times. Okay. So even with RNN knows, we will train all the models. Yes. Okay. Because why not? Sometimes some basic model will give you much better accuracy than deep learning models. Okay. So we should not forget about machine learning models. And this will work as your machine learning model project as well. Okay. So now here you can see we have 32 steps because you can see where exactly TQDM is added. Okay. So after executing for 1.5 hours, this is what we have. Now, once we have all the models, what I can do, whatever we are having. So if you look closely, I have initialized a trained model list, a trained model dictionary. Inside this dictionary, I'm saving everything. I'm defining the name of the model, the exact model itself with the current weights, the train MAE, train RMSE, test MAE, test RMSE. I'm saving everything for the model so that at the end I can compare. And if you look here, this is the list that I have. And this was the dictionary that I'm converting into a data frame. And now I'm sorting this data based on test, mean, absolute error. What are the best models that are giving you the least mean absolute errors? And actual, how many models do we have? You can see that as well. This is model.csv. Okay. How many models do we have in total? I have trained total 415 models. They are not 32. 32 are the steps. So sorry, 417 models. Okay. They are every step. In every step, we are training multiple models. Okay. So these are the models that I have trained. And I don't only have like the model name. So you can see linear regression I have trained on open column for 30 days. Rich open column for 30 days. Lasso open model for 30 days. Deep copy is not defined, error occurred. Okay, then import deep copy function. Okay, ask ChatGPT, it will write you the code to import deep copy function. Where exactly do we have it? So probably the code arises here. So here I might have the function of deep copy, deep underscore copy. Okay, so deep copy is not imported here. So there's an issue in this code. So make sure to import deep copy function, and it's pretty simple. Ask it like import deep copy. So it will call the library, from the library it will call deep copy function and probably add it here. Hopefully it will add it here. Otherwise it will problem for me that I need to manually change it. So import deep copy and it will work. Rest of the things would be fine. So from copy import deep copy, now the code will work. Okay, so let's go back from import copy. Yes, that's doing the exact same thing that is done here. Okay, so here you can see I've trained all these models, not only every model, which model, and this is nothing but the exact model weights that we can import. Train MAE, test MAE, test, train RMSC, train and test. So based on that, I can see which model is working the best. And eventually I can go back here, and here you can see I've sorted the best performing models. These are the best performing models. These are top 50 best performing models among all the 400 models. Can you see any common pattern in this? Can you see any common pattern in this? All of them are machine learning model. Yes, this is first part. Okay, why deep learning models are not there? Because for deep learning models, I've defined just 10 epochs. I need to train it for multiple epochs. Deep learning model would be at the top as well. But let's leave it right now at there. So here you can see most of them, which are giving you the least MAE, are trained on high column. Like almost all of them are high. That means which column I should take? High column. In the beginning, I don't know anything. I was like, which one I should take? Let's take open column. But there is not one with open column. There was one with close. Okay, one with open as well. Thank God. But most of them are with high column, right? And one more thing, which model is working in general the best? So here you can see on top, we have linear regression, KNN, Ridge. These are the main ones. Okay. And apart from that, how many days I need to go ahead with? 30, 60, 90, 120, how many days? That's something that I need to think about. Again, the top two are 30 days, but then we have eventually 90. We also have 250. So what I can do now, I'll plot some graphs to get the things more clear. So here you can see the same data that you have seen here in graphical format. Okay, and now I'm finding the relations. So here you can see if I'm taking top 50 models with lowest test MAE, most of them, either I can take 30 days, 90 days, or 120 days. All of them have a trade-off. I should not take 45 days, 150 days. They have comparatively the least MAE. Okay, so how many days I should go ahead? Just go for 30, 90, 120. Okay, this is first thing. This will tell you how many days I should take. Okay, why ME matrix is used? Okay, I'll tell you at the end. ये भी एक बार मुझे दोबारा से याद करवा देना please. Like what is this MAE matrix? Why can't we use accuracy? Okay, so this one will tell you how many days should I take. I can definitely take, rather than taking 50 models, I can take top 100 models. I'll get a better plot. Now this one will tell you which column I should take. Now this is a clear win. This is a very clear win. I should go for high column. यहाँ पे फिर भी I need to rethink like 30, 60, 90, but यहाँ पे 200 भी तो बहुत पास ये एक ही तो कम है. These are definitely a lot lesser, but this is a clear win. If you want to make a model, make sure to make it based on high column. Why? Because among all the other models, high is working the best. Okay. And which model I should take? Among top 50 models, KNN is almost 18 of it. Then we have rich, then we have linear regression of model type. Then we have random forest. There is no deep learning model right here, but deep learning models will be there. Deep learning models will take a lot of time to train that I have not given. I've trained all the model for standard 10 epochs. Okay. Even if you go back in the training loop, you can see for how many iterations I have trained those. I trained those models. So in the training part, this is training machine learning model. This is training deep learning models. So model, we are expanding it. Model.fit. I'm training all the models for just 10 epochs. If I'm going for 50 epochs here, definitely the training time will take around 5 times the time. Right now it's taking, for example, 1.5 hours. Then it will take like 5 hours. But definitely you will get some even better results. Okay. So the thing is, if I'm going back, yes, okay, I'll make sure I'll say everything in English. So if I go back, I can train it for more number of epochs as I mentioned. Rather than going for 10, I can go for 50 epochs. So then here in this list, you can also see some deep learning models. But this one, basically from this one, I have decided how many days I should take, which model will work the best, and yes, which model will work the best. And eventually what I have done, I have saved all the models. All the 450 models I have saved. So if you are executing this whole code, eventually it will save all the models as well with the name train models.joblib. Joblib is the extension when you want to save models, specifically multiple machine learning models, also deep learning models. Okay. And then you can load any of the model as well. Here you can see I'm loading the loaded models. Once these loaded models are loaded, eventually this is just a dictionary. So I can pass knn underscore high underscore 90. This one will give you the input. This one will load the model, and inside the loaded model of model, this is the model that I have. So if I'm executing it, this is the exact model that I have. This model has like train RMSE, all these things, and I can also use this model to predict on X90 of fifth row. So open X90 means I am taking 90 days input, fifth row of it, because I have multiple of such inputs, give it to the model and the model will predict the output as well. Okay, so this is the whole notebook. In this notebook, we are training more than 400 models. Okay, and eventually after training all the model, I got to know which model will work the best. Okay, and what are the 17.5, 17.5? It is actually 18. This is basically telling out of top 50 models, KNN appeared 18 times. In the list of top 50 models that performed the best, KNN appeared 18 times. This is a big number. Okay, and Ridge appeared 10 times. This appeared almost 8 times, 8 or 9 times. This is the data. Okay, eventually what you can do, just add more number of epochs for this one for training the deep learning networks, and you will get the better answer here. Okay, but our data is sequential, so going with ML model is okay. Yes. Eventually, what do you want? I want a model that will work, that will give you the best accuracy. Doesn't matter if it is a machine learning model or a deep learning model. Okay. Okay. Results on 120 days high columns can model is more accurate. Yes. Okay. So are you guys clear about it? What is the whole pipeline? Then I'll summarize it. Okay. Why MAE's matrix is considered instead of MSC? It's not something like which one you should take. You can take both of them. That's totally fine. If if we have MAE less, MSE will also be lesser. Okay. Now the thing is, what are these matrices? MAE, MSC. Okay. Eventually, whenever I am making a classification based model, for example, if I want to make a cat versus dog classifier, for example, this one. So For a model to see if the image is of a male or a female is easy, right? For example, I have given 100 images. Out of 100 of them, if my model is predicting 60 are male, 10 are like 40 are female. So you can easily calculate how effective your model is. What is the exact accuracy? Accuracy basically means total output versus correct outputs. You can easily find it in a classification based problem. But the main problem arises when I have a regression based kind of a problem. When I have a regression based problem, then the issue is, imagine if my model is predicting the output should be 14.5 or 1400.5. This is what my model is predicting. And the actual output is 1400.4. So the answer is correct or not? This is the actual value, this is the predicted value. The answer is correct or not? The answer is not correct, but it is very close. So in regression kind of a problem, the model will give you very less accuracy because accuracy is not the game. It's about how far my answer is from the actual output. That should be the main answer, right? So in this particular kind of a thing, I'll go for mean absolute error. Mean absolute error means what is the difference between this one and this one? This is zero point 0.1. And this is not something we'll find for one row. We'll find out for all the rows. So if I'm finding it for all the rows, so it will give you the average mean absolute error. Okay. And in the exact same way, we also have root mean squared error, mean squared error. So there are different formulas through which will calculate it, but usually all of them are indicating kind of the same thing. Okay. Now I have a question for Anand. If I need to predict for more days, then should I train model to predict more days or use the previous output and use the input to get output for next day? Okay, this is a good question. Now the thing is, imagine if I am going to the same data set. Inside this data set, we have the data till which date? Okay, let's do one thing. Let's go for this one. Okay, so I already have a model, right? So what I'm going to do, I'm going to take this model dot predict and I want to predict it for the last row, x underscore test of -1. Okay, the data is shuffled. Okay, let's do one thing. Data is shuffled. Okay, that's fine even if the data is shuffled. No worries. I'll take the original data frame. Okay, just look closely what I'm doing. I'm taking, now this model is trained on which column? On open column, right? So I'll take open column and how many days of the model will take as an input? 60 days. So I'm taking last 60 values. So these are last 60 values, right? These are last 60 values. And here you can see of which day do we have it as well. Okay. Now what I want, I'll take last 60 days values as an input. I'll check the length of it. If it is exactly 60 or not, it is exactly 60. I'll convert it into a list just to see it in better manner. So this is the data that I have. Can I pass this data directly to my model to get the prediction? So I need to reshape it. Obviously, I need to expand one dimension. Sorry, np.expand underscore dims of this. And I also need to add an axis is equals to probably 0. Incomplete. Okay, sorry. So now here you can see what my model has predicted. My model has predicted this particular value. So now tell me if I'm showing you df.tail. So my model has predicted this value of which particular date? My model has predicted this value for which specific date? Of 27th, right? Because if you look closely to this data that I have shown you, this 24914.35 is the data till this one. So I'm taking from this date previous 60 days data and I want to predict the next day's data as an output. So the output I am getting is, so basically this particular data is the value of, is the stock prediction of 27th of May. Does this make sense? Right? So this is of 27th of May. What if I want to predict the data of 28th of May? Include this as an input. Exactly. So what I'll do in that particular case, look closely, okay? I'll take this data, the already have data. This time, rather than taking 60 days, I'll take last 59 days. That's the data that I have, right? I'll convert it into a list. This is the data that I have. And inside this list, I will add this data that my model has predicted. So this one dot append this data as well. So eventually I have a list with previous 59 days data plus what my model has predicted. Now this resultant I'll give to the model again, and the model will predict one more day of data. Does this make sense? So this is basically I'm getting the prediction from the model and feed it back to the model as an input to get the next day data. Okay, if you take input 61 days data rather than 16 days, can we predict better? Okay, we cannot give 61-day data as an input. Reason being, it seems like if I'm taking this and rather than passing 60 days, if I'm giving 61 days, the model will not predict. It's not because of this extra comma, but the model is designed to take 60 days input, not 61 days. Okay, so this is sliding window pattern again. So what we usually do, okay, just to make your life a bit easier, let me train it for 5 size batch so that you can easily see what's happening as well. Okay, so this is the data of last 5 days. I'm giving this data to the model. My model is predicting this should be the data of next day, 27th. So what I'll do, I'll take now the data of not only these 5 days, but this time I'll take only these 4 days. But along with that, I also want to append one more value here. I need to see how exactly should I expand it. Okay, so I think this one dot append this whole thing. Okay, this might be a mistake that I'm doing, but okay, let's go ahead. I need to convert this whole thing into a list first and then append it. Incomplete input. This will be converted into list dot append. Okay, I'm doing a mistake probably. So this dot append, okay, let's take this. These are the 4 values, right? So I'll take these 4 values along with the value that my model has just predicted. That is this one. So I'll take these 4 values along with that, the model predicted value. Let's go for just 2-side thing. And then I need to expand a dimension into it, and probably I need to convert into numpy array as well, but no. So now my model has predicted this. Now this is the stock price of day after tomorrow, right? Does this make sense? Does this make sense? What's happening? I'm taking one extra day data, feed it back to the network. Then one extra day data, feed it back to the network again. So basically, if I am giving the code to GPT, it will write a function for me. Obviously, I can also write the function by myself, but this is just an additional thing that I'm giving. Okay. Now go to get the prediction for next n days. Okay. Write a function for prediction. Okay. So to write a function for prediction, so this is forecast for next 10 days. You can pass the model, you can pass the data frame, you can pass the column that you want. Okay. A minimalistic one without any. Okay, let's go ahead with this one. This one will give you the prediction. So let's run it to see if it is working or not. So I'll pass my model here and I'll go for the window is 5. The number of days are 7. So here I need to make sure the window is 5 because the model will take 5 days input. So here I've defined window 5 and let's pick this as an output. So it will take okay. This is the stock price of next couple of days that my model is predicting. The model is forecasting. Okay. And I can also go for plot it in graph. So I can now this code will plot it in the graph. And that's great. So I can basically plot it what should be the stock price of it in next 5 days. So this is the existing days of data that I have till here. This is the data till here. On 27th was the last day till what I have the data. This is what my model is predicting. This is what my model has predicted. Then I'm taking this model as an input. Then this is the next one. This is another one. So you can see this is very linear. Yes, this is very linear. Okay. And one very problematic thing here is, can you tell me what's the problem in this? Obviously the data is linear. That is one thing. It's a scatter plot. No, this is not about the plot. It's about the model. First thing is it is plotting it as a line. Okay. Because again, machine learning linear regression model, if I'm talking about here, if coming back to the same point, if you are using a deep learning model, so then it will not be that sequential. Okay, it will have a lot of waves as following here. So if you are taking a deep learning model, applying it here, so then you can see a lot of noises there. It will make the wave exactly like this. This is one thing. Second thing is, imagine from day one, I want to predict the stock price of tomorrow, right? It will give you the best fit. If I want to get the stock price of day after tomorrow, so to get the stock price of day after tomorrow, first of all, I need to get the stock price of tomorrow. There will be some error in stock price of tomorrow. If I'm feeding that to my model to get the day after tomorrow, the error will be increased. Does this make sense? Error will add up, right above. And if I want to go for day after tomorrow and a day after that, it will increase further. So the more you will go ahead with, the more it will mess up. Okay, that is the main issues with getting the prediction for very far. So the best thing you can do, get the prediction for tomorrow. You will get the best kind of an output. Okay. And if you want to go for like for next 1 month, what is going to happen? So this is not something we should be doing. In the exact same way, this is for investment kind of a thing. Okay. Can I have a trading bot as well, which will trade for every minute, every second? I can also have a trading bot. to have a trading bot, this data set will not work. Because for this data set, I have one day, for the whole day, I just have 4 values. But in trading data, I need to have the data of every second, how the data is changing. Okay, so that's also a very important thing that I need to make sure. Okay, anyone having any doubt on this project, do let me know. Otherwise, I'll discuss about the assignment now. Do let me know in the chats. Okay, can we include sentiment analysis news alongside the stock with the real-time prediction as well? Yes, we can add it. Okay, the more functionalities you are adding, the better your model will become. Thanks, Apurv. So we're talking price data, but not the factors which can affect stock market prediction. That is a pretty important question you have raised, Narendra. Stock price does not only depends upon the stock price of yesterday or historic data. It also depends upon a lot of other factors. Okay, for example, what is happening around the globe? That's also an important factor, and that's kind of the most important factor. Okay, we call it butterfly effect. Okay, so you cannot exactly predict something. Anything can happen in between. For example, one recent incident is COVID. So किसे पता था, like who knows exactly, because of something this much downfall will happen. Exactly, Shiva. Okay, so there are Trump. Yeah, that's also a perfect example. Okay, how frequently we should train this model? Okay, can you do one thing? Like you can train this model, and after that, for next day, I just have one extra row. Retrain it on the existing model again. We can do it, right? Because now I don't need to retrain the whole model. I just need to add one extra row. And for one extra row, it's not mandatory. You can retrain it probably in 15 days and a month. That's totally up to you. And till you see how everything is working, bagging and boosting. Yes. So for bagging and boosting, let me go to Excel draw. And after that, I will discuss about one very important thing, that is the assignment. So AI2 diffusion, AI2 Gen, this is on machine learning workflow, machine learning algorithm, probably ML, ML goes probably this one. Not sure, but let's see. Okay. This is the one. Okay. So basically in bagging and boosting, in both of the things, rather than having one model, we usually take more than one model. Okay. For example, here you can see I'm training a model for class A, and this is the output, how the model is predicting. It seems like, okay, rather than thinking of bagging, think of it as this way. Rather than having one expert, I have 10 experts. I'll take advice from all 10 of them and then see what I need to do. So I have better chance of making correct decision, right? This is exactly what bagging is. Rather than having one model, I'll take 10 models, I'll get the average output out of it. Like what most of the people are saying about this. So out of 10, 7 of them might be saying you need to go there. 3 of them might be saying go there. So I need to go for the average out the things. So this is what bagging model is. Rather than having one model, I'll use multiple models. Okay. In the exact same way, in boosting, I'll have an expert who is good at a lot of things, but there are some problem with that person. So whatever problems that we have, I have one more expert on that thing, but they also have some more problems. So their problem again, for that purpose, I have one more expert. So the limitations of one model are given to another model, limitation of that model given to another model. This is boosting. So these are two very important technique, bagging and boosting models. Okay, very simple. Okay. That's what we did in this project. Okay. Yes, basically we have used kind of a bagging technique. Rather than having one model, I've used multiple models. I've trained them and seen how each model is performing. But eventually to get the prediction, right, this is also something you can do. Very important point. Okay. Listen closely. Rather than having one model to give you the output, can I take top 10 models, get the output out of them and see if all of them are saying the stock price will go up? I'll say stock price will for sure go up. If three of them are saying stock price will go up, two of them are saying stock price will go down, I'm not pretty sure. But if all of them are saying stock price will go down, I'm pretty sure. This is what bagging is. You can take 10 models, 20 models, 30 models, get the prediction out of all of them and see how consistent these outputs are. Okay. Bias variant trade-off. Okay. There are a lot of terminologies that will come for sure. So for now onwards, like for now, just do one thing. Let's see what we need to do as an assignment. Okay. So your assignment is pretty simple. If you are executing this whole notebook, you will get the important models, important classes, right? For example, here we got to know high is the column I need to take. Close, low, and open are not needed. So if these columns are not needed, I just need to retrain whenever I want to make a new model and train it again. I will use high. And whenever I want to use which model I should use, I will just use top three models. Why should I go for random forest, light, BGM, and all the other machine learning models if I know these are the top two models that will work? So rather than training 400 or 400 models, you will just have couple of models to train. Okay. And for the assignment, just give me a minute. I'll share you the notebook. Okay, the exact notebook. And the meantime, if anyone has any doubt, do let me know. So it is 21 days, 21 projects. Just give me a second. So this is the notebook. So what I'll do, like I'm not able to find it. So what I'll do inside this existing notebook, I'll add the text here. So your task is to, first of all, finalize just the important things. For example, we have finalized the high column. So take only high column. Take only the main 2, 3 machine learning models. Like I know which models are working the best. KNN, KNN is working the best. So I'll take KNN. But along with that, I'll take all the deep learning models